Hi everyone, we're going to look at some areas between curves. That's what this video is all about. It's going to be working out the area between different curves. We started this before looking at examples, areas between curves and the x-axis. And one of the key understandings we wanted was in doing this question and recognizing that areas above the curve are counted as positive, areas below the curve are counted as negative. So this question asking about, is the shaded area equal to the integral between b and a? So looking at the ones where it's a problem, looking at C, we'd see that the little area over here, which I'm highlighting, that would be counted as negative. This other area here would be counted as positive. And therefore, if you did the integral from b to a, you'd get, let's say, 2 and minus 1. The integral would spit out 1. And clearly the area between the curve and the x-axis there is actually 3 total, 2 above and 1 below. So you just have to be careful with areas above and below the x-axis. And in part D as well, that's a problem because when you worked out that integral there, you'd get a negative number. So it doesn't make sense to say an area is negative. So D is also wrong. So that's an important understanding about areas underneath curves. Just want to look at these two questions here, so we can write these in our notes. This one here, for each of the graphs below, calculate the shaded area in each case. So the way that you do these is, if you look at the previous page, it is the area basically underneath the top graph minus the area underneath the bottom graph. That's it. So if I could write out the area of that first section there, first I would want to know what that point of intersection is there. So I want to know when sine 2x is equal to cos x. Okay, so sine 2x, which is the top graph, I want to know when that is equal to cos x. That's the first step here, isn't it? So we do that. Well, sine 2x is 2 sine x cos x. Clearly, it's not 0 we're looking at. So if I put x equals 0 in there, that's not going to be what we're looking for there. It's positive. So I could technically divide both sides by cos x here. And then I would get 2 sine x equals 1. Sine x equals a half. So x must be 30 degrees, or let's do it in radians, pi over 6. So now I know that this point here is pi over 6. Okay, so the area between the curve, between the two curves, is the area, is the integral from pi over 2 to pi over 6. What's the graph that's on top? That's the sine 2x graph minus cos x. That gives you the area between the two curves. Okay, finish that off and tell me what answer. Sorry, that's pi over 2 to pi over 6. Finish that off and tell me what answer we get. Okay, here we go. So the integral of sine 2x is negative a half cos 2x. The integral of negative cos x is just going to be plus sine x. Sorry, negative sine x. Negative sine x. And that is all between pi over 2 and pi over 6. So we now substitute in. So I've got negative a half cos pi minus sine pi over 2. You've got to be really careful at this step that you don't make a mistake. Really easy to make a mistake here. Negative a half cos 2 times pi over 6 is pi over 3 minus sine pi over 6. So just go through all these really carefully. So negative a half, cos of pi, cos of 180 degrees is actually negative 1. Sine of 90 degrees is 1. This next bracket here, negative a half times cos of pi over 3 is a half, minus sine pi over 6 is a half. There we go, so we're looking at the exact value here. So we're looking at a half minus 1 minus, and in this bracket here we've got negative a quarter minus a half. minus 3/4. Okay, so we've got a half, negative a half, plus 3/4, which I'm going to say is 1/4, or 0.25, and I guess you could say unit squared if you wanted to. Great, that is the area between those two curves. Now if we wanted to do part B here, we've already got that area there, we've just worked that out. So then what the nice thing about this method is that it doesn't matter if the area dips below the x-axis here, as long as you just say the top curve minus the bottom curve, you'll still get the correct answer. So to work out the area between pi over 6 and negative pi over 2, in this case the top graph, the one that's on top, is the cos graph. So we'd say cos of x minus sine 2x with respect to x. That area there will give me that bit there, and then we can add on the value that we found from the previous one. If you work that out, you should get 2.25 for that. We add on the 0.25, and your final answer is 2.5 units squared. One more. Let's look at this one where we've got a quadratic and a line. We want to work out the area between the two. Again, even though the area goes below the x-axis, it's cool. As long as we just say the top one minus the bottom one, the formula works. So in this case, the area is the integral. So we need to know some points of intersection over here. So we want to find when, let's do it over here, x squared minus 2x minus 1, when it intersects with the line x minus 1. And I can kind of see from my diagram here that it's going to be 3 and 0 for the x values, but you could use this equation here, get a quadratic and solve it. But I can see it's going to be 3 and 0 from my nice accurate sketch. Now what is the curve on top? In this case the line is the one on top. So we'd say x minus 1 minus x squared minus 2x minus 1. Okay, so the top one minus the bottom one. So we can do some algebraic simplifying here. So we've got negative x squared, x minus negative 2x is x plus 2x, which is plus 3x, and negative 1 take off, negative 1 is negative plus 1, which is just 0. There we go. So the 1's cancelled out there. So now we can do the integration. There we go. That's a nice easy integration with polynomials. Finish that off and tell me the answer. Okay, here we go. So obviously substituting 0 in for x there and there is just going to leave us with 0. So it really isn't necessary to do that part. We know that the second bracket there is going to be 0. That's cool. So we just got negative 27 over 3, which is negative 9, plus, and this one here we've got 27 over 2. So negative 18 over 2 plus 27 over 2, so it's 9 over 2 unit squared. All works out nicely.